Okay, so this video is all about surface areas of 3D shapes. Be sure to check out the PDF, which is on MathsUpgrade.co.uk. Download it and have a go at these questions. So the first question gives us the surface area of a cube as 294 centimeters squared. And we're asked to find the volume of the cube. So the way I'm going to do that is we're going to find the area of one face of that cube. Then we're going to find the length of the edge. And then we can find the volume of that cube. So let's do that now. To find the area of one face, well, since the total surface area is 294 and there's 6 faces and the equal faces, I can do 294 divided by 6 using short division. That gives me 49. Now, since 49 is the area of one square, to find the edge of one square, I can just square root 49 and that gives me 7. So 7 is the edge length of that cube. To find the volume, I can just do 7 times 7 times 7, which is 343 centimeters cubed. The whole question there is 4 marks. Question 2. I'm given a solid square-based pyramid VABCD. And I'm told that the base of the pyramid is a square of side 6, the height is 4 centimeters, and M is a midpoint of BC, with VM being 5 centimeters. The first thing I'm asked to do for 2 marks is I'm asked to draw an accurate front elevation of the pyramid. So to draw an accurate front elevation of the pyramid, all I have to do is simply imagine I'm looking at the pyramid from this direction of the arrow. Since all I'd see is a triangle, I have to draw a triangle on this grid. What I have to make sure I do is make sure I draw accurately, bearing in mind that this is a squared grid. So it would look something like that. There's that face. Since the face is 4 centimeters vertically and 6 centimeters wide, I need to draw a triangle which is 4 centimeters high and 6 centimeters wide. For part B, I must find the total surface area of the pyramid. To find the total surface area of the pyramid, what I'm going to do is I'm going to first of all find the area of one triangular face. So I'm going to find the area of this face first, then I'm going to find the area of the base, and then I can use those two to find the total surface area. Since the area of one face is just the area of this triangle, I can just do base times the height of this triangle. Bear in mind I have to use the height, which is the sloped height here. So let's do that now. So the area of one triangular face, that's going to be base times height divided by 2. 6 times 5 divided by 2 gives me 15. The area of the base, well, the base is just a square of edge length 6. So 6 times 6 is therefore 36. The total surface area is the area of all these surfaces combined. So it's 4 lots of the triangle plus the area of that base. 4 times 15, add 36, will give 96 centimeters squared. That part of the question is 4 marks. Combined with the first part, the whole question there is worth 6 marks. Okay, so the rest of the questions in this clip are all calculator questions. So question 3. The diagram shows a cube of side length 2. Vera says the volume of any solid made with 6 of these cubes is 48 centimeters cubed. And we have to explain whether Vera is correct or not, showing all working. So first of all, I'm going to find the volume of one cube. Then when I find the volume of one cube, I can find the volume of all 6 cubes. To find the volume of one cube, I need to remember the volume is given by the length times by the width times by the height. So length times width times height is 2 times 2 times 2, which is 8. Since there's 6 cubes, 8 times 6 is 48. So yes, Vera is correct. So with question 3b, we're asked to draw a cuboid that can be made with 6 of the cubes. Write the dimensions of the cuboid on our diagram. So the way I'm going to rearrange my cubes, there's different ways of doing this, but essentially I'm making a 2 by 3 cuboid. So here's my cuboid. It's 2 cubes deep, 3 cubes wide, and just 1 cube high. We can make different versions of this. You could, for example, make 6 cubes across and just 1 cube deep and 1 cube high. So I've written the dimensions on here. The length is 4 centimeters, the width is 6, and the height is 2 centimeters. Now I need to work out the surface area of my cuboid. The surface area is essentially the area of all the surfaces, all the faces, okay? So the visible faces are the ones which we can actually see on this diagram, and they'll obviously be the invisible faces which we cannot see. So the left-hand face here is going to be 4 centimeters by 2 centimeters. It's essentially just a rectangle. So 4 by 2, 4 times 2 equals 8. The front face in blue here is going to be 6 centimeters wide, 2 centimeters high. So 6 by 2 is 12 centimeters squared. So that's the area of the front face. And the top rectangle here is going to be 6 centimeters wide by 4 centimeters deep. So that's 6 times 4, which is 24 centimeters squared. And that's the top rectangle. So all the visible faces are 8, add 12, add 24. So that's 44. That's the visible faces. Now there are also the same number of faces which are invisible, which are behind this diagram, okay, on the other side, which you cannot see. So since they're identical to the visible faces, we just need to double this, and that would give us the total surface area of that cuboid, and that is therefore 88 centimeters squared. And that would be the 2 marks for that question and 5 marks overall for the entire question. Question 4. I've got a sofa which has got 6 identical cushions. Each cushion is a cuboid 18 centimeters by 80 by 95 centimeters. The cushions are protected with a spray, and it comes in cans. The label on each can has information on it. So each can cover 4 meters squared. We need to work out how many cans are needed to cover the 6 cushions with protective spray. This question is worth 5 marks. So the way we're going to do this question is we're first of all going to find the surface area of one cushion in meters squared. We need to find the surface area since the can covers the cushions. So it's a question involving surface area. It's not a question involving volume, since the spray doesn't go inside the cushion. Okay, so it's covering all the surfaces of the cushion. Then we find the total surface area of all 6 cushions. That's because there's 6 cushions in total. And then we divide the coverage of each can into that total surface area, and that will give us the number of cans needed. So essentially, these are the steps we need to follow here at the bottom. So let's find the surface area of that first cushion. So essentially, the faces that you can see here are all just rectangles. The left rectangle, the left face here, is 95 centimeters by 18 centimeters. I'm going to turn these dimensions into meters first of all. So this would be 0.95 meters, since 95 divided by 100 is 0.95. Similarly, this would be 0.18 meters. So when I multiply those two together, I'd get 0.171 meters squared. For the front, it's 0.8 times 0.18, and for the top, it's 0.8 times 0.95. So there's the surface area of that first cushion. The total surface area of that first cushion is therefore going to be all those 3 faces there added together, but then doubled, because obviously I've got the 3 hidden faces and they're identical to the 3 visible faces. That would give me 2.15 meters squared. Now, since there's 6 cushions in total, as mentioned in the question, if I then multiply that by 6, that gives me the total surface area that I need to cover with the cans. Since each can cover 4 meters squared, if I divide this value by 4, that tells me how many cans I need to buy. The answer is 3.225, but since I can only buy whole numbers of cans, if I buy 3 cans, it won't quite be enough cans to cover the cushions. So I need to buy 4 cans, and then obviously I'll have a little bit of spray left over, but 4 cans is what's needed. That question was worth 5 marks. The next question here, part B, gives us a little bit more information. It says that the label is inaccurate. The spray in each can actually cover 10% more than 4 meters squared. And we're asked to find how will that affect the number of cans needed for the 6 cushions. We need to show how we get our answer. Well, 10% more than 4 meters squared, 10% of 4 is 0.4, because simply this can be divided by 10 to give 0.4, which is 10%. So 4 meters squared add 10% is 4.4 meters squared. 4 meters squared add 10% is 4.4 meters squared. So now if I do the same calculation here, 12.9 divided by 4.4, that gives me 2.9. And since 2.9 is actually less than 3 cans, right, I only need now 3 cans to be bought. Last time I needed 4 cans, but since each can cover slightly more, I only now need 3 cans. So that is what my statement says here. So you've got your maths to back it up. You need to write a sentence explaining that only 3 cans are needed and it's 1 less than previous. The whole question there is 2 marks. Altogether, the entire question, 7 marks. Question 5. I've got a diagram showing a cube and a cuboid. The total surface area of the cube is equal to the total surface area of the cuboid. So that is a known fact. We need to see if Janet's statement here is correct. She says that the volume of the 2 shapes are both equal. And we need to show how we get our answer. And that would be 5 marks. The first thing I'm going to do is I'm going to find the surface areas. Since they're both equal, if we find the surface area of the cuboid, that will be the same as the surface area of the cube. And that's a known fact. Then the second thing I'm going to do is I'm going to find the cube's edge length from its surface area. When I've got that, I can find the volume of the cube, and then I can compare that with the volume of the cuboid, and then I can state whether Janet is right or wrong. So let's go ahead and do that. So here's the steps I'm going to take. Step 1, to find the surface areas. Well, the surface area of this cuboid is quite simply the area of the front and the area of the right hand face, the area of the top face, add those together and times by 2, since these are just the visible faces and there's obviously identical hidden faces behind. So the front face is 6 times 8 as a rectangle, the right hand face is 18 times 6, and the top is a rectangle of 18 times 8. If I multiply those together and times my answer by 2 with a calculator, I get the total surface area of 600 centimeters squared for this cuboid. That is also the surface area for the cube as stated here. Part 2, I'm going to find the edge length of the cube. Since I know the surface area of that cube, I can find the edge length. Okay. First of all, the total surface area is the area of all the faces. Since there's 6 identical faces, I can find the area of each face by just dividing this by 6. That gives me 100. Then, since each face is a square, I know the area of each square is 100, I can square root this to give the length of each edge. So square rooting 100 gives me 10. So this edge is 10, that edge is 10, and that edge is 10. Now I can straight away find the volume of the cube, knowing that the cube is a 10 by 10 by 10 cube, so the volume is 1000. For the final step, I can find the volume of the cuboid. Okay, I can find the volume of the cuboid just with these dimensions already given to me. And I could have done this at the start. So I just do 6 times 8 times 18. Since the volume is obviously the length times width times height. So that is 864 centimeters cubed. Now I can compare this volume of the cuboid with this volume of the cube. If they're the same, then Janet was correct. If they're different, then Janet was wrong. And you can see they are different values, so therefore Janet is definitely wrong. That question there is 5 marks. Question 6. We're told that Jeremy has to cover 3 tanks completely with paint. Each tank is identical and it's in the shape of a cylinder, as in that diagram there. We're told that diameter is 1.6, the height is 1.8. And we're told that Jeremy has got 7 tins of paint in which he can cover these 3 tanks. But each tin of paint can only cover 5 meters squared. So we need to work out whether Jeremy has got enough paint to cover the tanks, clearly showing our answer, and that would give us 5 marks. So the way we're going to do this question is we're first of all going to find the surface area of one of these cylinders. Okay, so since this involves surface area of cylinders, make sure you're familiar with how to find areas of circles. Okay, if you're not sure on how to find areas of circles, look back at the YouTube clip on areas of circles on my channel. Once I find the surface area of one cylinder, I can then multiply that by 3 to find the total surface area that needs to be painted. Then I can find the total coverage of 7 tins and compare those two values. Let's do that now. So here's the steps we're going to take. Okay, the area of the top here is just a circle, and that's given by the area of a circle, which is pi r squared. The area of this curved face here is given by the circumference of this circle times by the height of this cylinder. The circumference of this circle here is given by 2 pi r and the height is h. So the area of this curved face is 2 pi r h. You can imagine this as just a rectangle when it's rolled out. The width of the rectangle would be 2 pi r and the length would be h. So the total surface area is given by 2 pi r h, add 2 lots of pi r squared, and that's what's given here in this formula. When I substitute in the radius of 0.8, as given in the question here, since the diameter is 1.6 and the height is 1.8, using a calculator, that gives me 13.07. Since there's 3 of those tanks to be covered, I've multiplied by 3, that gives me 39.21. Now this is the total surface area which needs to be covered. Each tin can cover 5 meters squared, and there's 7 tins altogether. So that would give me 35 meters squared coverage. So is that enough paint? Well, no, it's not enough paint. I need another 4 or so meters squared to be covered, so it's less than what's needed. And I'd write a sentence explaining that as well for those 5 marks. The whole question there is 5 marks. Question 7. The diagram shows a solid metal cuboid. The areas of the 3 of the faces are marked on the diagram. The lengths in centimeters of the edges of the cuboid are whole numbers. The metal cuboid is melted down and made into smaller cubes. Each of the cubes has got sides of length 2.5. Work out the greatest number of the cubes that can be made. So with this question, we need to find, first of all, the length, width and height of that large cuboid. Once we've found that, we then need to find the volumes of the cuboid. Then we find the volumes of the small cubes and divide them both. So to find the length, width and height, the big clue here is that the fact that they're all whole numbers. Okay, I need to essentially solve 2 equations simultaneously. If you're not sure on how to solve simultaneous equations, you need to look at that YouTube clip on my channel, and that should help you through that. Here's the steps I'm going to take. Okay, I need to essentially solve length times height as being 45, width times height as being 15, and length times width as being 27. Okay, and here's my length, width and height labelled on the diagram. Okay, you can solve these just by inspection. Okay, but assuming you can't do that, I'll show you the general method. The length times height I know is 45. So length I can rearrange to be 45 divided by the height. The width times height is 15. So I can rearrange the width to be 15 divided by the height. If I substitute these two both into length times width as being 27, then I get this equation here. Then multiplying this equation together, these two terms, I get 45 times 15, which is 27h squared. And then quite simply, I know that therefore h is 5. If h is therefore 5, I know that the width is 3 and the length is 9. Next, I'm going to find the volume of that whole cuboid and know the measurements. So the measurements are 5, 3 and 9. To find the volume, just multiply the length, width and heights together and you get 135. The next part of this question, you need to find the volume of one small cube. Since each cube has got a length of 2.5, then I know that the volume is just going to be 2.5 multiplied by itself and multiplied by itself again. So 2.5 cubed is 15.625. The last part of this question is to see how many of these cubes I can create from this entire volume. So I'm simply dividing these two values through and then rounding down to the nearest integer gives me 8. The reason I need to round down is because I need to work out the greatest number of cubes that can be made. Okay, so the answer there is 8 and the entire question there is 5 marks. Question 8. I'm given a solid pyramid here. I'm told that the base of the pyramid is a square of side 20. The angle between any sloping edge and that plane ABCD is 55 degrees. And I need to find the surface area of this pyramid. Give my answer to two significant figures for 5 marks. This question involves both Pythagoras, trigonometry, as well as surface area. So if you're unfamiliar with Pythagoras or trigonometry, look at the videos on this channel to help you further. Here are the steps I'm going to take. I'm first of all going to use Pythagoras to find the length of AO. The AO is this length here. I've labelled this as O because it's directly underneath the apex. Once I've found AO, I can then use trigonometry to find the length of AV, which is in essence this edge length here. When I found AV, I can find MV, which is the length of the sloping face there. Once I've got those dimensions, I can find the total surface area of this pyramid. So the first step then is to find AC. Once I've found AC, I can just divide it by 2 to get AO. AC can be imagined through this right angled triangle here. Since this is a square, this corner of this base of the pyramid must be a right angle, and the shorter sides of this triangle are 20 and 20. So in essence, I can do 20 squared, add 20 squared, square rooted to give the length of AC. When I divide that by 2, that gives me the length of AO. Now that I've found AO, I can use that value, and I can use this angle given to me here of 55 degrees to find AV. So here's AO and here's AV. So in essence, what I've done here is I've imagined this triangle AOV like this. The angle here is 55 degrees. The value for AO is what I just calculated a few seconds ago. And I know that AV and AO are related through the cos ratio. So since cos is adjacent divided by hypotenuse, the adjacent is AO, the hypotenuse is AV. If I rearrange this equation here, I can find AV, which is 24.66. The third part of this question, I'm going to use Pythagoras to find MV. MV is this diagonal height of this pyramid here. So MV can be imagined with this diagram here. So what you've essentially got is you've got two right angle triangles. Okay, I've split that entire diagonal face there, the sloping edge, to create two right angle triangles. Since I know that the length of AB is 20 and the midpoint here is just halfway between them, then I know that that distance there is 10. I've already worked out AV previously as 24.66. So to work out VM, I can just use Pythagoras for a second time in this question. This time I need to subtract since I'm working out a shorter side. And that would give me 22.54. The last part of this question is what the question's all about really, and that is to find the surface area. The total surface area is the area of this triangular face multiplied by 4 since it's identical with the other three, added to the area of the base. So that's what I've done here. So the area of a triangle is base times height divided by 2. Right, since the base is AB and the height is MV, I've got those values here. Substitute those in, substitute in the base of the triangle for the area of that square, and the final answer is 1301. So to two significant figures, that would be 1300 centimeters squared. The entire question there is worth 5 marks. Question 9. This is arguably the most difficult question in this booklet since it involves surface area, Pythagoras, but most importantly it involves solving quadratics. If you're not sure on how to solve quadratics, feel free to look at the video clip on this channel to support you further. I'm given a solid cuboid which has got a volume of 40 centimeters cubed. The cuboid's got a total surface area of 100 centimeters squared. And the only other information I'm told is that one edge of the cuboid has got a length of 2 centimeters. I need to find the length of a diagonal of the cuboid. A diagonal is essentially the distance from one vertex, one corner of the cuboid, directly to the opposite vertex of that cuboid. If I give my answer to 3 significant figures, showing all my working, I'll get 6 marks for this question. So first of all, let's label on the measurements that we're given, which is 2 centimeters here. I don't know the height, so I'm just going to use the letter H, and I don't know the length, so I'm going to use the letter L. The steps I'm going to take are these here. I'm first of all going to form an equation for the surface area. I'm then going to form an equation for the volume. I'll use both equations to find the length and height. And once I've done that, I can then answer the question in terms of the length of the diagonal by using Pythagoras. So the first step then is to find the surface area of this cuboid. Since the surface area is double the area of the front face, it's double the area of the top face, and double the area of that side face there, okay, I can then basically equate that to the known surface area, which is 100. So that's what I've done here. Area of the front is 2h, area of the top is 2l, and area of the side is hl. I need to add these together and then need to double it, since I've got 3 hidden faces behind this diagram. So expanding that bracket there would give me 4h plus 4l plus 2hl, and that equals 100. Now, if I just leave that equation for now if I form another equation for the volume, I'm told that the volume of this solid cuboid is 40 centimeters cubed. I also know the volume of a cuboid is given by the width times the height times the length. The width I know is 2, the height I've given the letter h, and the length is letter L. So width times height times length is equal to 40. If I then divide both sides of this equation by 2, I'm given HL equals 20. But then make L the subject of this equation by dividing by h on both sides. I've got L equals 20 over h. What I'm now going to do, I'm now going to substitute this equation for L into this equation which I formed earlier. So that's what I'm doing here underneath. So now I've got 100 equals 4h plus 4 lots of L, which is 4 lots of 20 over h, plus 2 lots of HL, which is 2 times h times 20 over h. If I then neaten up this equation and then take 100 to this side by subtracting 100 from both sides, I've then formed a quadratic equation. From this step to this step, I'm just going to multiply through by h on both sides and then divide by 4. So rearranging it into the form of a quadratic equation and then applying the quadratic formula. Again, if you're not sure how to do this, look at the clip on this channel. That gives me h as being either 13.52 or 1.479. These are both valid solutions. They're both valid solutions since when I substitute them both into this equation here to find the value of L, I get the opposite value. So essentially, I've confirmed these as solutions. Now, I've now got the length, the height, and the width as given in the question. Since I've got all 3, I can now use Pythagoras to find the length of a diagonal. The length of a diagonal is essentially the length of this corner directly to the length of the opposite corner here. And Pythagoras in 3D states I can find that length by doing the square root of the sum of the squares of each of those edge lengths. And that's what I've used here. If you're not sure on how I've done this, again, look at the clip on 3D Pythagoras on this channel. The final answer is 13.7 centimeters, and that is good for 6 marks.